My name is Philip Christie from IMEX Services, and in this short 5-minute video I'd like to show you how trace analysis can be used to analyze the performance of a DSP. In this first example, we'll run a basic trace called DSP timing with our reference technology node. First, we list all of the directories containing our libraries, and from this directory list we will select the directory containing standard threshold voltage libraries. Once in this directory, we can list all of the standard cell libraries for all the different process corners which are available to us. And from this directory, we will run the DSP timing trace in verbose mode. And we shall select the standard cell library with the worst case process corner by using the -lib option. Once this corner has been selected, we can run the trace. As we can see, the runtime is just over 1 second. The intermediate results are printed out in the form of a timing report, and the total critical path delay is written out at the end. Now we illustrate how easy it is to swap in a new library into the DSP timing trace. We list all the libraries, and now we select the worst case process corner, but with a reduced supply voltage of 0.81 volts. Same runtime of around 1 second, and we see a significant increase in the critical path delay. In this example, we'll show how easy it is to change from an SVT library to an LVT library. We drop down one directory level in the directory structure, and now we'll move up to the LVT directory and list all of the libraries that are available to us. We'll again run DSP timing in verbose mode, but now we will select the worst case process corner for the low threshold voltage library. But that's not the end of the story, because now what we must also do is append the letters LVT to all of the cell names, which we do with the cell app command. And this basically adds the extension LVT to all of the cell names and enables us to run the low threshold voltage library with the original trace. Now we see in the intermediate results, all of the cell names have the LVT extension, and we again compute the new critical path timing delay. In this final example, we'll change from 40 nanometers to 65 nanometers. We move to the 65LP directory and now list all of the libraries we have available to us in that directory. From this list, we're going to select the 65LP worst case process corner, again running to DSP timing in verbose mode. But now we have to make one small modification of removing the BWP extension that was generated by the 40 nanometer implementation of the DSP using the cell replace command, which replaces the string BWP with a null string, thereby removing this extension from the cell names. Now we can run the trace. And we can see in the verbose mode that the extension BWP has now been removed from the cell names. If you need any further information about how traces can be used to solve your technology targeting issues, please contact us at tts@imec.be.